First question is, the table shows some physical quantities which row correctly identify the quantities as scalar or the vector. Okay, let's start with the A. Acceleration is scalar, no. Acceleration is vector, yes. Charge is vector, no. So C, it's not scalar, so you're only left with the D option, so it should be correct. Acceleration is vector, charge is scalar, kinetic energy is scalar, and wavelength is scalar. Okay, good. In the question 2, two quantities are measured. L and T are related to X by the equation given. What is the calculated value of the uncertainty? Okay, so what you have to focus on for the uncertainty, these two quantities. Okay, 4 and pi are the constants. First, let's find the value of X because we are going to need it. 4 into pi squared, L is this value is 6.8 and T is basically 4.2, 2.42, and there is a square on it. When you calculate, you will have 5.83. Okay, let's leave it as it is. Okay, let's sort it out. How many significant figures should be there? If you see, there are two quantities. One is this one is this one. This have two significant figure, this have three. So answer will have the least significant figure of the value from where you have calculating all of this. So this is the least significant figure 2. So answer should be rounded off to two significant figure. So it will be equals to 46 when you round it off. Okay. Let's find out the uncertainty. So we have to choose between C and D, and we are not the options. We know fractional uncertainty of X will be equals to fractional uncertainty of L plus 2 multiplied by fractional uncertainty of T. Why I'm multiplying with 2? Because of this power. This is called the power factor. Okay, this is the power factor. When some quantity have a power on it, you have to multiply its fractional uncertainty with it. So fractional uncertainty of X will be delta X over X, that is equals to delta L over L plus 2 delta T over T. So this thing is delta L, this thing is delta T, this is L and this is T. Okay, and X we also know. So delta X we need to find. Delta X, this X will also go on the right hand side, will be delta L over L. Delta L is 0.1, L is 6.8 plus 2 multiplied by delta T is 0.08 divided by 2.42 whole multiplied by the value of this is 46. Okay, so doing the calculation you will get 3.79, something like this. Okay, so if you see in this calculation how much you have to round it off, there are two values that you have used, this one, and they have the one significant figure. So the answer should also be one significant figure. So you have to round it off. It will be rounded off to 4%. Sorry, it's not percent, 4. Okay, so answer will be option D, that is correct. Okay, moving to the next question. What is the SI base unit of watt? Very easy question. You should know the formulas. Power is energy over time, or you can say work over time. Work is F into D divided by T. Now you can, I assume you know the units of force, distance and time. So force is kg meter per second square, distance is meter divided by the second. When you simplify this thing, it will give you B. Question 3. The diagram shows two forces of 6 Newton acting on an object. The angle between the line of the force is 60. What is the magnitude of the resultant force? Okay, so what I can do, I can make it into a perpendicular forces. How? I'm going to resolve this one. If you see, if I resolve this force to the component, this is 60 degree. This component will be 6 cos of 60 degree, and this component will be 6 sine of 60 degree. So this can be resolved into two forms. Its one component is here, 6 cos of 60, and one is there, 6 sine of 60. Now you can ignore this one because we have resolved it into the component. So the horizontal total force Fx, you have 6 cos of 60 plus 6. Vertical force, you have 6 sine of 60. They both are perpendicular. So from the previous knowledge of your IGCSE, you can apply the Pythagoras theorem formula, and F is equals to under root Fx square plus Fy square. When you do the calculation, you will get, let me try this, it will be 6 cos 60 plus 6 whole square plus 6 sine 60. It will give us 10 point something, almost it's 10. So it's option C. In question 5, a goods train passes through a station at a constant speed. Okay, so goods train is moving at a constant speed of 10 meter per second. And express train is at rest. Okay, there another train is express train that is at rest. The express train leaves the station with the uniform acceleration, okay, of this. Both trains move in the same direction, a straight line. At which time t does the express train overtake the good trains? Okay, it's a very common question. In case of overtaking, let's build the scenario first. Let's suppose if this point, this is the station, okay. There is one train that you can call, let's call this as a goods train, okay. And there is another train, let's give it a different color. This is the express train, okay. And this is the point where they're going to overtake each other, okay. So whenever this type of question they ask, you have to keep in mind time will be, for let's suppose this time is t1, this time is t2, you have to keep in mind time will be same. You can simply call it t. They both will take the same time, then they can overtake each other, right? And as if you say this distance as s1, this distance as s2, the distances should also be same, okay. There is no other way the train can overtake the other train, okay. So for distance is same, if you have to write down s1, s1 can be written as the speed is constant, so 10 is the speed multiplied by the time. So you can simply say that s1 is equals to 10t, okay. So when I do it for s2, s2 is accelerating, right? So we have to apply equation of motion. So s is equals to ut plus half at square is can be applied because we don't know the final velocity. So s2 is equals to initial is 0 into t plus half, acceleration is given, that is 0.5 into t2 square, okay. So it will be s2 is equals to 0.5 into, this will give you 0.25 t2 square, okay. So this is the equation, okay. So what we can do, we can use this thing. We know s1, let me make the space to write something, okay. We know s1 is equals to s2. So s1 was 10t and s2 is 0.25 t2 square. So what we can do, this t1 is equals to t2, right? This can be simply called as t, so I can simply write them as t. So they will cancel out with each other. This t will cancel out with this square, so t can be written as 10 divided by 0.25, that will give you 40 seconds. Okay, it's option D that is correct. In the next question, question 6, a ball is held above the ground and released. If it falls to the ground and bounces several times, the graph shows the variation with the time t and the velocity. 4 point on the graph or label which statement is not correct. This not you have to focus on. Okay, so incorrect statement you have to choose. In A, the area under line PQ represent the initial height of the ball. Yes, the ball is moving from this point top, it's moving towards the ground. Okay, so when it hits the ground, this is the u is 0. There will be velocity will be equals to maximum, that is point q. This is point q p. So this is exactly, so this is the true, it's not incorrect. The collision of the ball with the ground is are inelastic, that is also true. If you see, each and every time this ball is not reaching its initial velocity, its velocity will decrease. It means it's losing some of the energy. The gradient of the line rs represents the acceleration due to the free fall. Yes, the velocity time graph gradient shows you the acceleration, and the maximum upward velocity of the ball is reached at point P. Maximum upward velocity, how it can be reached at P? It is starting from the point P, so that will be the zero velocity, right? So it's option D that is correct. Incorrect. Okay, so that you have to choose. In question 7, an object is projected in horizontally. The object falls a vertical distance y and travel a horizontal distance x. A second object is projected horizontally with the same initial velocity and it's covering 4y vertical distance. Okay, assume that A resistance is this. Okay, what you have to keep in mind in this question, if you see this one is covering the x, you have to find it has covered distance x. Y is given, this has covered distance y, and this is covering distance 4y. So what comes to my mind, that this second object have more time to fall towards the ground. Its time is different because it is covering more height, right? So let's sort it out for both the objects. For object 1, when we do, okay, so x is, as you know, horizontal velocity is same, is constant, will not change, so you can write as x, that is horizontal distance, is equals to u, that is horizontal, let's write as ux, into time t. Okay, and time how much it has taken for this is horizontal I am talking about. When we talk about the vertical distance, I have to apply the equation of motion, that was s is equals to ut plus half at square. Okay, so for the first object, this is y, u is vertical velocity 0, I'm talking about the vertical components. So 0 plus 1 by 2, A is basically equals to G, because A resistance is ignored, yes. And T will be equals to, let's write it as T square. Okay, so I can say Y is equals to 1 by 2 GT square. Okay, let's try for the object 2, what we get. For object 2, it's a second is object, you have to find its, let's call it x1, this is y1, this is y1, so we have to find x2. X2 will be ux, that is same in both cases, and let's call this time t1. Okay, for that, so this is t2. Okay, so this for the horizontal component. When I talk about the vertical component, I have to apply same equation. I can apply same this one. So y2 will be equals to ut will be, u is 0, so it will be vertical component velocity, so it will be half g and t2 square. Okay, so what we have, I have to find t, so t2 is equals to 2y2 divided by g square root, right? So here you also find t1, just to relate, 2y1, this is g divided by g under the root. Okay, so what we have, what is given, that y2 is 4 times of y1. This is the condition given. Okay, so when you apply this thing, this will be 4y1 and divide by g. This thing will give you 2 when you take the square root of only 4, 2 times 2y1 over g. And if you see here, 2y1 over g is equals to t1. So t2 is 2 times of t1. Okay, t2 is 2 times of t1. Now I am going to find this thing. This is actually what we have to find. So x2 will be equals to ux into 2t1. It will give you 2 into ux into t1, and we know this thing is equals to x1. So x2 is equals to 2x1. So it will cover double the horizontal distance. It is option B that is correct. Okay. In question 8, a sphere falls from a rest through the air. The graph shows the variation in the time of the sphere, the velocity, which diagram shows the forces acting on the sphere when it is at the velocity corresponding to the graph. Okay, if you see at this point, the air resistance will be negligible, or you can say 0. With the passage of time, air resistance will increase. At this time, air resistance is significant, but it is less than weight. At this point, the weight and air resistance are same. So air resistance should be less than weight. Okay, so this is not the option, they are equal. This is not the option, air resistance more. This is not the option because there is no air resistance. So it's option C that is correct. Question 9. In which situation has total linear momentum always conserved? Total linear momentum. Achha. Total linear momentum is conserved in elastic and inelastic line. The only condition is the system should be isolated. Okay, so this is option C. Question 10. An object of mass m moving with velocity is given 9 meter per second, has head-on collision with a stationary object whose mass is 2m. Okay. After the collision, both objects are moving, no external forces acts on the system. What is the velocity? Okay, let's try to build the scenario. Here this left side is showing the before and this side is showing after. Okay, let's try to understand this thing, what they are trying to tell us. There is one object whose mass is m, whose velocity, let's suppose it is moving towards the right side. It's 9.0 meter per second. Okay, there is another object, double the mass, 2m. It is at rest. Okay, so total initial momentum initial will be mass into 9 plus 2m into 0. That will give me 9m, right? So what the idea I am getting, when it will going to collide this thing, this mass is less, so the most probably this will bounce back and this should move a little forward, as they have told us both are moving. So this will move backward, this will move forward. This is the only condition. Okay, possible if both are moving as per the question condition. So after cooling, the momentum should also be same, right? So this should, if I make a scenario, this is 2m, this is m, because this m is colliding with the larger object, it will bounce back, this will move there, and as you see, this direction we have taken positive, so 2m velocity will also be positive. Okay, so we can't choose option A and option B, we have to choose between option C and option D. Now look, if we choose option C, let's suppose, so if option C, for the sake of example, if velocity is 4.5 for this, its mass is already 2m, so its momentum will be 9m. Okay, that was equals to the initial momentum. So the final momentum should be same. So for making the total momentum 9, this should have 18m on the left hand side. Then you can say 18 minus 9 is equals to 9, but still this 9m is toward right side and this 9m will be towards the left side, so it's not making the scenario. Okay, because you have to satisfy all the conditions. The momentum should be conserved. Okay, so 4.5 is not the option. What option we have? Let's suppose, obviously it's option D, as C is not the option now. So D is correct. Why? Because let's suppose if this thing have a 6 velocity, mass is this, so its momentum will be 6 into 2m. It will give you 12m, right? But it should be 9. The total should be 9. So this can have 3 velocity towards side, so 3 into m will give you 3m. So 12m minus 3m can give you 9m, and this 9m is towards the right hand side. This was also toward the right hand side, so it satisfies the condition. Okay, so in question 11, the graph shows how the momentum of a motorcycle changes with time. What is the resultant force on the motorcycle? Okay, so very simple question. F is change in momentum over time. So momentum was initially 0, it is 5000 at this point, and time is 10. It will give you 500 Newton. Option A. Pretty easy question. Question 12. A rocket has a weight of W and an initial acceleration of A. As the rocket leaves the ground vertically, the acceleration is g. Which expression gives the initial upward force exerted on the rocket? Okay, let's try to build the scenario. There is some. Let's suppose this is a rocket, it's moving upward. The weight will be acting down. The F up force, let's suppose it's acting like this. Resultant force should be resultant force, because it's accelerating upward, should be F up minus weight. We have to find F up, so that will be resultant force plus weight. Resultant force is ma plus weight is, okay, which option we have? A is not the form that we are looking for, and B, C. Okay, A can be. We can write M as M is mass. It can be written as weight divided by G. Remember, weight is equals to mg. So you can change this thing, W over G. This is A plus W. That is the F up. Look, it's option A. Question 13. Let me move this thing up so we can have space for the working. Question 13. A uniform rod of weight 28 is supported at one end by the force F. The rod is in equilibrium and attached with the hinge. What is the magnitude of the force? Okay, so the main point is it is in equilibrium. There are two forces. One force is this and the other force is this acting on it. Okay, so what we have to look at, this thing will make a anti-clock movement, and this thing, actually you have to find the component of this thing. This will be the its component for the, if this is 40, this will also be the 40-degree angle. Okay, so this component will be 28 cos of 40 because it is attached with the angle. So we have two forces. This force will produce a clockwise movement. Okay, so for the anti-clockwise movement from the pivot point, this is the length. Let's call this thing as L. And for clockwise movement, this is, let me change the color, this is the length that we have to consider. Let's call this thing as L by 2 because it will be the half of the length. So clockwise movement is equals to anti-clockwise movement. Clockwise is 28 cos of 40, that is the force. L by 2, that is the length, is equals to anti-clockwise, that is F is the force, L is the length. Okay, you have to find F. This L will cancel out with L. This F will give you, F is equals to 28 cos of 40 divided by 2. Solving this thing, you will get 10.72, that is nearly 11. Option B. Question 14. Two forces, each of magnitude F, acts in opposite direction on a rod. Each force acts on the rod at a distance d from the pivot P. What is the torque of this couple? Torque is simply the force acting on it and multiplied by the distance between the two forces. The distance is 2d, so it will be F into 2d. It can be written as 2ft as well. Okay, so this is the option. Question 15. A man of weight 600 newtons stand with both feet flat on the ground. What is a reasonable estimate of the pressure exerted on the ground by the weight of the man? Okay, so pressure is force over area. Force is equals to its weight and area. Okay, so area of the feet you have to estimate. You have to memorize that area of feet can be 0.06 meters square. Okay, or you can say 600 centimeters square. Okay, so it is 0.06 meters square, so it will give you 10,000 pascals. It's option C. Question 16. The formula for the up thrust on the block is given. What does the symbol rho and V represents? Okay, rho represent density of water. Yes, V volume of the whole block. Whole block? No, it is the volume of the block that is submerged into the liquid. Okay, B density of, sorry, this rho is also not a density of the water, it's a it's density of a water. Okay, density of a water, so this is correct, this is correct. And actually, these are not the density of the wood, so C and D are not the options, so most probably it is B, volume of the block below the surface. Yes, okay, it is submerged into the liquid. An object with a mass of 100 gram falls a distance of this. This is mass, changing gravity. Okay, so you have to convert mass into kg. It will be 0.1 kilogram. Okay, and this, so change in GPE is mgh. M is 0.1. This is 9.81. This is 10. This will be 10. Okay, so it's option B. Question 18. A bungee jumper jumps from a platform and it's decelerated by an elastic bungee cord as shown. When the bungee jumper makes the jump, his initial gravitational energy relative to the ground is converted into kinetic energy. Okay, at which part of the jump are all the three types of the energies are non-zero? Okay, on the platform before the jump, no. Before the jump, the kinetic energy is zero, the elastic potential energy is zero. Okay, on the way down before the cord has started, before started to extend, then elastic potential energy will be zero. So this is not the option. On the way down as it decelerate, okay, when it decelerate, when the cord, when this thing will stretch, right? So at this point when it is decelerating, GPE is not zero, kinetic energy is not zero, and elastic potential energy is also not zero because the cord is stretching, right? It's option C that is correct. Question 19. A sailboat is pushed by the wind at a constant velocity v. The force of the wind and the velocity of the sailboat are in the same direction. Which additional information is required to determine the burden per unit time? Okay, so basically they're not naming it, but they are asking you about the power. So V is given, so P we know it is F into V. So if V is given, you need the force. So it's very easy, option A that is correct. Question 20. A spring is fixed at one end, the length L of the spring is increased. You have to find elastic potential energy. Okay, so for elastic potential energy, we have relation half F into X. So 1 by 2 when F is 6.0, X is initially is 8, then it is 12, so it is 4 centimeter. Centi is minus 2. So doing the calculation, you will get 0.12 joules. It's option A, that is correct. Okay. Question number 21. They're telling us a wire has an unstretched length of 2 meter. Okay, so this you have original length and stress is given, and the new length of the wire is 2.1 and it obeys the Hooke's law. What is the Young modulus of the wire? Okay, so the relation for the Young modulus we have E is equals to stress divided by strain. Okay, so stress is given here. You have 1.6 10 raised to power 5. Okay, what the strain is basically change in length divided by original length. Okay, so this was the original length, this is, let's call it a final length. So change in length is final length minus initial length, so you can write as 1.6 10 raised to power 5. This L will come here and X will go there. It will be 1.6 10 raised to power 5. Original length is 2.00, whereas change in length is 2.10 minus 2.00. Doing the calculation, it will give you 3.2 10 raised to power 6. It's option D that is correct. In question 22, what are the SI base unit of stress? Stress, we know it is force per unit area. Force, we know it is MA divided by A. Now you can put the units. For M, we can write kg. For acceleration, it is meter per second square. For area, it is meter square. So it will give you kg per meter per second square. So it's option B that is correct. In the next question, question 23. The diagram shows a force extension graph for rubber band as the band is extended and then stretching force is decreased to zero. What can be deduced from the graph? Okay. The rubber band does not return to the original length when the force is decreased to zero. Okay, if you see the graph, this is the rubber band when there is a force applied on it, it's stretching. And when you remove the force, it's going back to the original point from where it started. So it is reaching the original length. X-axis is showing the extension. So extension is again zero. So this is wrong. In B, the rubber band obeys Hooke's law. For the extension shown, no. For Hooke's law, it should be a straight line. The rubber band remain elastic for the extension shown. Yes, it is elastic, okay, because it's coming back to the original shape. And the D is the shaded area represent the burden in extending the rubber band. No, the D is the shaded area shows the energy lost during this process, okay, not the burden. In question 24, which row is correct for sound wave? Okay. Can travel in vacuum? No, it's true. Yes. Okay, so B is not the option. Can be polarized? No, it cannot be polarized. Okay, so C and D are not the options. So we are only left with A. Can be deflected through the gap. Okay, so it's option A is correct. In question 25, a source emits a progressive sound wave in horizontal direction. The wave travel away from the source in a direction towards the right. The graph shows the variation of displacement of the particle from the equilibrium position with distance from the source at a particular instant in time. Okay, and the displacement to the right of the equilibrium position are shown. Okay, Acha, this graph is basically, it's not the displacement time graph, it is the distance time graph. Okay, so that you have to keep in mind. X-axis is showing the distance. So position y represent the displacement of a particle in the sound wave at a particular distance from the source of from the source at this instant. Which statement about the motion of this particle is correct? So you have to tell what this particle y is showing. So if you see this particle will, its displacement will reduce, right? So it's when displacement reduced at this point, displacement is zero. So when displacement is zero, it's mean you are moving towards the source. It's option B that is correct. In question 26, two polarizing filters are placed next to each other so that their planes are parallel. Okay, and the first polarizing filter has its transmission axis at an 50 degree to the vertical. Okay, so the second polarizing filter has its transformation axis 20 to the vertical. The angle between the axes of the two is 30. The beam is vertically polarized. Okay, so let's try to make the scenario. Let's suppose this is the beam. Okay, this is vertically polarized. Again, it's going to move from the first filter, and this first filter is 50 degree to the vertical. Okay, its transmission axis, you can say it's 50 degree. Okay, so as it is initially vertical, this is 50 degrees. So when you apply the Mole's law, if and the coming intensity that is going to, okay, a beam vertically polarized of intensity 8 watt per meter square. Okay, this is going to strike, this intensity is 8. Okay, point 0. When it go out, how we can find it? You know the Mole's law, I is equals to I naught I naught cos square theta. So this will be, the remaining will be 8 into cos square, and theta will be 50 degree, because the angle between the light coming and the transmission axis is 50 degree. So that will give you 3.305. Okay, now 3.305 light that is polarized in this direction 50 degree to the vertical is moving, and then there is another polarizer here. Okay, okay, and this polarizer transmission axis is, the angle between the transmission of two polarizing filter is 30. Its angle is 30 degrees. Okay, so now this is basically 3.3, and this angle is, if I make this, sorry, this is not the light is coming from, if I make this vertical line, the light is coming like this. The light is now polarized at 50 degree, and the polarizer axis is basically making angle with this thing, that is the angle between them is 30 degree. Okay, 30. So this is what you can say, this is the polarizing light, and this is the angle transmission axis of the polarizer. So this is the angle between the coming light and the filter. So this is 30 degree that you have to consider. So it will be 3.305 cos square 30 degree. So this thing will give you 2.475. It's almost 2.5. So it's option B that is correct. Okay. In question 27, a dolphin is swimming at a speed of 16 meter per second. So this is the speed of the dolphin. Let's call it Vs, directed towards the stationary underwater microphone. Dolphin emit a sound. So this is the frequency of the source. The speed of the sound is V. This, what is the frequency of the sound detected by? So we have to find F naught. So applying the Doppler's formula, F naught is equals to Fs V divided by V plus minus Vs. As it is moving towards, so you will take negative sign. Okay, so F naught is equals to Fs V divided by V minus Vs. Fs, you know, is 122, Okay, kilo is its minutes in thousand, multiplied by V is 1480 divided by V minus Vs 1480 minus 16. So this thing will give you 12333.33. That can be rounded off to 123 kilohertz. It's option D, that is correct. In question 28, a student carries out a double slit experiment. Okay, this is from diffraction grating. Okay, so a student carries out a double slit experiment using a laser emitting red light of wavelength, that is the lambda. The light is incident normally on the double slit. The diagram shows a part of the pattern of the bright fringes visible on the screen at a distance of 2.4. So that is the separation between the slit and the screen. This is D. The distance across five bright fringes is given, that is 34. Okay. So what you have to find the slit separation. Slit separation is basically A. What relation we have? Relation we have for the diffraction grating, lambda is equals to AX over D. Okay, we have to find A, so it can be rearranged. A is equals to lambda D over X. Okay, I have lambda, I have D as well, I need X. So if you see, the separation between the two slits is equals to X. So this is again X, this is again X, and this is again X. So you can say 4x is equals to 34 millimeters, mean 10 power minus 4 meters. So x is equals to 34 multiplied by 10 power minus 4 divided by 4 meters. Okay. And what else I need? That's it. Now I just have to put the values using this relation. What you will get, A is equals to lambda is 680 nanometer 10 power minus 9 multiply by D, that is 2.4, divided by this whole expression 34 into 10 is to power minus. You can simplify it. I'm directly putting the values. Doing the calculation, you will get 1.9, 10 is to power minus 4 meters. Option C, that is correct. Okay, so moving forward, question 29. The diagram shows the stationary waves on a stretching spring at an instant in time t. Two particles on spring P and Q are shown. Which statement about the vibration of P and Q is correct? So you have to keep in mind it's not progressive wave, it's a stationary wave. Which statement about is correct? They have the different frequencies. Why? They have the same amplitude. No. They have different periods. No. They are in phase. Yes. Anything between these 2 points, what I am mentioning here, will be in phase. Okay. Green laser light passes through a diffraction grating. Again, diffraction grating question. Above one was, sorry, it was a young double slit. It was double slit question. Okay. This is now diffraction grating question. What we have, the diffraction grating is containing 400 lines per millimeter. You have n. The wavelength is given. You have lambda. What is the highest order of diffraction of maxima? You need to find n. So basic relation is what we have, n lambda is equals to d sine theta. You have to find n is equals to d sine theta divided by lambda. For n maximum, theta should be 90, so sine 90 is 1. So this will be d by lambda. So lambda I already have, I need d. So d, we know d is basically equals to 1 over n. Okay, so if we know n is equals to 400 lines per millimeter, if there are 400 lines per millimeter, So in meters, how many lines will be there? It will be, as meter is 1,000 times greater than the millimeter, so there will be 1,000 times more lines. Okay, so there will be 400,000 lines per meter simply. So d is 1 divided by 400,000. Just put the values here. D is 1 divided by 400,000, and lambda is 6 8, no, it's 550, 10 raised to power minus 9. Okay, doing the calculation, I will get, it's 4.54. Okay, you always round it off towards the downside, so it will be 4. Okay, question 31. There is a potential difference V across a resistor of resistance R. The current in the resistor is I. Which equation give the power dissipated? First is P is equals to VI, that is incorrect. It should be P is equals to VI. P is equals to V square over I, that is incorrect. This is P is equals to V square over R basically. P is equals to V square into R, that is also incorrect. There is no such relation. P is equals to V square over R. Yes, that is correct. Option 32. What is possible charge in the particle? Okay, what you need to know that charge is basically n multiplied by E. So whatever the charge is, that should be multiple of, E is 1.610 raised to power minus 19. Whatever the charge is, that should be multiple of this thing. This n is integer. Okay, so what you have to do, you have to take the ratios of them. So if I try the option A is 6.4 10 raised to power minus 20 divided by 1.6 10 raised to power minus 19. If it gives me a integer number, so then it will be a correct option. This is giving me 0.4, that is wrong. Okay, 0.4 is not possible. It can be 1 electron, 2 electron, 3 electrons, or any number of electron, but it should not be in a ratio in fraction. Okay, so for B it is 4.00 10 raised to power minus 19 divided by 1.6 10 raised to power minus 19. That will give me 2.5. That is also wrong. C 1.12 10 raised to power minus 18 divided by 1.6 10 raised to power minus 19. That will give me 7. Okay, so there are 7 electrons, they are making this charge. Question 33. The graph shows possible current voltage characteristics for a filament lamp and for a semiconductor diode. Which to identify the IV graph? Okay, so this is for lamp, because with the increase in voltage, current is not increasing. This is no one. This is for the diode. Okay, so it's option A, that is correct. Question 34. The diagram shows a circuit containing battery and a cell with a negligible internal resistance. Some values are given. What you have to find, R, resistance of this thing. Okay, so if this 3 is coming here, this will be going there. Okay, to find the R, we need the voltage and the current through P. Okay, so I'm trying to sort it out. So if 2 is coming from there, it will be there. So 2 is coming from this point, 3 is coming from this point, so this will be 5 ampere. So current is 5, I know. I need voltage. So I have two different loops. I'm going to choose this one because there we have the data. Total EMF should be equals to Kirchhoff's second rule, right? Total EMF should be equals to total potential. But if you see, this positive terminal is with the positive terminal of this EMF, so they will be subtracted. So it will be 9.0 minus 1.0. This is the total EMF, should be equals to total potential difference. Potential difference through this one will be 2 into 3 IR, voltage into the current, and through this thing will be plus 5 into r. Okay. Okay, so I can directly find r from there. You don't need this thing. Okay. You need current, but you don't need this equation. So rearranging this, 8 is equals to 6 plus 5r. So r is equals to 2 by 5. Okay, this will give you 0.4. Option A. Question 35. The diagram shows a circuit with a battery connected to a resistance R. The battery has an internal resistance. Okay, a second resistor identical to R is connected parallel to this thing. Actually, what you are doing, you are applying another R parallel to this R. Okay, you have to tell what will happen to the potential difference across this thing and current across this thing. Okay, if you see, when you attach another parallel resistance here, the total resistance of this, let me highlight this thing. You can say total resistance decrease. If total resistance decreased, then I can say total current increase. And as resistance is decreasing, their potential difference share decrease here. And if this decrease, this will lead towards this thing, that potential difference across this increases, because total should be constant. So both will increase. Current will increase and potential difference across R will also increase. Question 36. Two identical wires X and Y, each of length L and radius R, are connected in parallel as shown. Okay, what you have to do, the total resistance of this combination is R1. Okay, and wire X is replaced with the same material of length L and radius is double. You have to find the ratio. Okay, first you have to understand the relation basic. We have R is equals to rho L over, let me write it down here. R is equals to rho L over A. Okay, let's call this resistance R. This resistance is also R initially. So I can say, and they both are in parallel. So for the parallel combination, 1 over R1, that is initial, is 1 over R plus 1 over R. Okay, so it will give you 2 over R. It's mean R1 can be written as R over 2. Okay. When you are increasing the radius to the 2R, then this thing, this resistance, when R changed to 2R, area will be 4 time increase, because area is square of radius, right? And if area is 4 time increase by this basic relation, we have that resistance will be R by 4. So I can say the new resistance of this will be R by 4 and this will remain R. So their combination is R2. So 1 over R2 is 1 over R by 4 plus 1 over R. Simplifying this thing, it will be 4 over R. Okay, it will be 5 over R. So R2 is R over 5. So when you take the ratio, R1 is R over 2, R2 is R over 5, R will cancel out, is 5 by 2. It's option D that is correct. Okay. Question 37. The diagram shows the current in part of an electrical circuit. The resistance are identical. Which equation is not correct? Okay, not correct. Okay, I1 is equals to I2 plus this thing. Okay, if you see I4 plus I5, this is I3. So I can say I1 is equals to I2 plus I3. So this is correct, it's not wrong. Okay, I B option I2 is equals to I1 minus I3. Okay, so I2 is equals to, okay, so this is the total current. As we know, I1 is I2 plus I3. So I2 can be written as I1 minus I3. Okay, it's option B. Sorry, that is also correct. We have to choose incorrect. In C option, I2 is equals to I3 plus I4 plus I5. No, that is incorrect. Okay, so C is the option. Moving forward, question 5, question 38. The diagram shows a sequence of radioactive decay involving 3 alpha and. Okay, so let's try to sort it out. Alpha, you need to know alpha is 4 2 and beta negative is 0 minus 1. So when alpha will be removed, this 237 will be, you have to subtract 4. So it is 233, and from 92 you will subtract 2, it will be 91. Okay, beta mass will not change, charge will be 1 increased. Okay, it will be 92. Then again alpha, then you have to subtract 233 minus 4, so it will give you 229, and 92 minus 2 is 90. And then last one again alpha, again minus 4, 225, and 90 minus 2 is 88. Okay, so it's option, sorry, this is not the option, A is the option. Moving forward, question 39. The number of electrons in a neutral atom of isotope plutonium is given, is changed to produce an atom ion W. W has an overall charge of this. Okay, this atom is changed into an ion, and that ion has a charge plus 1.6. That is, it means it's losing one electron. So if it lose one electron, it was having 94 proton and electron. Now it should have 93 electron and 94 protons, and neutron will remain same. Option A. Question 40. Which particle is a lepton? Very easy question. It's option B. Okay, that's it. See you with the next paper.